Hi everybody, and welcome to the first video on macromolecular design. Well, in this series of videos we want to see how we can design the macromolecules in order to synthesize the polymeric nanoparticles. Well, we will start with different polymerization techniques. We will see how they work, we will see their advantages and disadvantages to prepare the macromolecules. Each of the polymeric techniques that we are going to introduce have their own power in order to design the macromolecules. But what is exactly a macromolecule? In order to have an understanding, an image of the macromolecules, just have a look at these macromolecules that we have here. Well, you see that the first one is just a combination of the monomers of A and B, and you see that they seem to be connected to each other in a random manner. However, for the second one we have the homopolymer at first, so you see that they are composed of the same monomers at first, and then again the random combination of different monomers. And you see here that for these macromolecules we have the side chains, and in this one there is something like a star, or you can say hyper branched. There are too many branches here. Well, the ability of producing different types of the macromolecules, as I said, depend on the type of polymerization technique that we are going to use. The polymerization techniques will have effects on the repeating units, on the molecular weight, and on the branching. You see here that we have the side chains and also the functionality, having the end terminal groups that we can use for example, connecting the targeting ligands here and the drugs and etc. Well, the main aim, as we mentioned within the previous videos, of the molecular weight and the colloidal size, is to prepare the nanoparticles which are going to have the same size and which behave identically within our body. In the matter of polymeric nanoparticles, in order to reach the uniform behavior of all the polymeric particles in the body, and in order to make sure that all of them have the same size, if you remember, the most important thing is to make sure that all of them have the same molecular weight. So this is important, having the same molecular weight. And because they will form the coils and the micelles based on the molecular weight, if we control this factor, we will make sure that they will behave identically. But how can we control the molecular weight? Well, it's easy, literally it's easy, but the concept is simple. If we just control the number of monomers which are in our polymeric chain, we will have control on the length of our polymeric chains, and we will have directly control on the molecular weight. So the important aim for us is to choose the polymerization strategy which helps us to control the number of monomers that are going to connect to each other and form the polymeric chain. Well, we will start with the worst method, the least useful polymerization strategy, named as the free radical polymerization. And then we will continue with two other polymerization techniques named as the raft polymerization and ROP, ring opening polymerization, and also another technique, the atom transfer radical polymerization, ATRP. So within the next videos we will introduce 4 different polymerization techniques, and as I said, the least useful in the matter of giving the control over how many monomers are going to connect to each other is the free radical polymerization. So let's start with that in the next video.